Good afternoon, everyone. I hope you can see the screen. The angle that I've chosen for this presentation is to make the link between the importance of securing critical minerals today in order to realize a clean energy system tomorrow. And I would like to start to talk about the Paris Climate Agreement. In 2015, over 190 countries ratified this agreement, a very unique event in the history of mankind, with so much commitment from so many different countries to battle global warming. And these countries agreed to limit global warming to well below 2 degrees Celsius. Now, obviously, doing that is a very big challenge. It's a daunting task, as you can see in this graph here. If we were to limit global warming to 2 degrees, we would seriously have to reduce GHG emissions, let alone if we go for 1.5 degrees Celsius that Brad was referring to in his speech. That means most likely reducing the GHG emissions with 50% by 2030. So it's a daunting task. At the same time, it also offers business opportunities, especially for those companies that are looking at electrification opportunities in, for instance, transportation, and companies that are active or want to become active in renewable energy. There is another aspect, which is energy savings, but that is beyond the scope of today's presentation for me. So electrification of transport is a very nice opportunity to help reduce global greenhouse gas emissions. As you can see from the graph here, the yellow line represents transport. So transport is really one of the biggest emitters when it comes to economical activities. However, greenifying transportation and electrifying transportation is just one of the first steps really to contribute to the targets of the Paris Climate Agreement. It is very important that the backside of that electrification process, i.e. Power generation, also becomes cleaner. Therefore, what we will see over the next coming years is that renewables and clean energy technology will take a larger portion of the energy mix. As you can see here, by 2050, Bloomberg New Energy Finance projects that things like solar PV, wind farms, and battery storage will take a larger portion of the energy mix as today. Now, the challenge with these things is that clean energy systems, such as solar, such as wind, but also electrical cars, require more critical minerals than their fossil fuel-based counterparts. So to give an example, electric cars require 9 times more critical minerals than a conventional internal combustion engine car. The same applies for solar and wind. An offshore wind farm requires 12 times more critical minerals than a natural gas-fired power plant. So where is the opportunity then, you might think? Well, the good news is that all economic powers in the world, from Europe, China to the US, have electrification of transport as their top priority. The focus is a little bit different. So Europe is very much focused on reducing greenhouse gas emissions, and their target is to reduce that with 55% compared to 1990. China is very much focused on building a domestic independent EV supply chain. But the message for all these 3 big economic powers is the same. All of them will invest heavily in EV and in EV infrastructure. And that explains also these numbers that the IEA presented in April this year. As you can see from this graph, depending on the scenario that we're looking at, net zero, in a net zero situation, EVs and battery storage will become the biggest contributor to the demand of critical minerals. So what is required to supply that the critical minerals that we need to accelerate the green and clean energy transition? We need 2 things. First of all, we need quality resources. basically good mines. And we need good mines to produce enough critical minerals. As you can see from this graph from Macquarie Research, they expect that next year we will reach a deficit for lithium, for instance. That creates bottlenecks when it comes to the mining capacity. But the same applies to refining. You need to refine the critical minerals that you mine before you can actually put them into the batteries or in the EVs eventually. And at the moment, there is not sufficient global refining capacity to meet the demand for high purity metals. So there are 80 billion reasons to look at mining and processing. And the reason why I say 80 billion is because of this graph. If you look at this graph, a lot of money is flowing into the downstream applications of green tech, so lithium batteries and EVs. But the expectation is that by 2025, there will be 1 terawatt hour of demand in lithium battery capacity. Now, 1 terawatt hour in demand requires 800 tons of lithium, 200 tons of nickel, and 800 tons of cobalt, and 625 tons of natural graphite. So that's a lot of ingredients that are required to go into each battery cell. And all these minerals require conversion and processing to upgrade the minerals into battery grade before they can go into the battery. Now, how does it look like for Europe, for instance? A very brief case study. Europe wants to have 10 million EVs sold in 2030. If we suppose that, if we assume that the average EV has battery pack of 60 kilowatt hours, like the Tesla Model 3, then Europe alone will need 600 gigawatt hours in battery capacity. And that 600 gigawatt hours will require 360,000 tons of lithium carbonate equivalent. And to put that in context, that's today's global production, meaning in the next decade, Europe will need as much lithium as the whole world is producing today. So that's a tremendous task. On top of that, Europe wants high energy density batteries. They want high quality batteries. In order to reach that and to get that, they need to refine the lithium as well. So there will be another layer on top that could create bottlenecks, which is the refining capacity, as you can see here. 80% of today's refining capacity for lithium hydroxide takes place in China. Europe at the moment has zero capacity for refining. So how to seize these opportunities? Basically, I would say invest in upstream, invest in mining and early processing of critical minerals. But then as soon as you have done that, on the back of that, try to get a partnership with people downstream, whether that is a battery producer or an EV producer. What that will bring you is two things. First of all, by bringing in the downstream end user, you will be able to modify your product early on, and that will save you cost, and it will help you in the marketing of your product because you basically tweak your product to meet the demand downstream at an early stage. But most importantly, today, most Western countries are looking for clean products. They are looking for products that have a clean ESG track record. And by having partners that put a lot of relevance and importance on ESG requirements early on in the process, you will make your life easier, and therefore also the marketability of your product easier. And in the end, you will have a higher chance to put a premium on top of your product. So how could it look like? This is a one-page summary. Suppose you get lithium offtake, like Bangchak. You could then work together with a processor and the tier one end customer, for instance, an EV manufacturing company, and really try to work together to clean the product, make it of higher purity, but in a way that meets the ESG requirements from the end markets. And with that, I've reached the end of my presentation. I would like to thank you, everyone, and also, again, AWR Lloyd and TMA for giving us the opportunity to share our thoughts on this.